Hello guys, in this video we are going to discuss the solution of the problem find number of islands. So let us look at the problem statement. The problem statement says given a grid of size n by m, n is the number of rows and m is the number of columns in the grid consisting of zeros and 1, and 0 represent water and 1 represent land. Find the number of island. Note, an island is either surrounded by water or the boundary of a grid and is formed by connecting adjacent lands horizontally or vertically or diagonally, that is, in all 8 directions. So for instance, if this is the grid which is given to us, in this grid, as we can see, all lands are connected to each other, because of which there exists just one island, and that is what we are returning over here. In the second example, there are two islands which is possible over here. The first island is composed of these lands, and the second island is composed of just one land, because of which we are returning 2. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the grid which is given to us, and we need to count the number of islands. So the idea behind solving this problem is to iterate through the grid and look out for land. So for instance, we are iterating through the grid and we are looking out for land. So let us say this is the first land which we have encountered so far. Once we have encountered a land, what we are going to do is we are going to perform DFS from this land. So assuming that this is the source, we are going to perform DFS from here. So essentially what we are doing over here is we are checking its neighbor, and over here, as mentioned in the question, we need to check in all 8 directions. So we need to check up, we need to check down. Similarly, we have to check left and right, and at the same time we also have to check the diagonals. So this is my upright, this is down left, and the other diagonal as well, upper left, down right. So we are going to check in all these directions. So from this node we are going to check in all 8 directions. So let us do that. So as we can see that this node is reachable from the source, because of which we are going to mark this node also as visited. So this node is also visited. Similarly, we are going to mark all these nodes as visited. Since all these nodes are visited, then all these nodes form one big island, and the number of islands we are going to update by 1. So let us say we have a variable where we are storing the number of islands. So that value we are going to increase it by 1, and this becomes equals to 1. Now we will move forward, and since all these nodes are already visited, then we are looking for the next node or next land which is not visited. This is the next land which is not visited, and there is no neighbor to this land. So this land in itself is an island, because of which we are going to increase the number of island by 1. So then the number of island becomes equals to 2, and this is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the number of island and a grid is given to us. So what we are going to do over here is we are going to take a visited matrix, and this is a 2-dimensional matrix, and all the values are initialized to false, and the size of this 2-dimensional matrix is equals to the size of grid. Next we are going to take an answer and we are going to set it to 0, and then we are going to start iterating on the grid. So for that, I in range of len of grid, and for j in range of len of grid of I, and we are going to check if grid I comma j equals to 1, which simply means it is a land. If it is a land and it is not visited, then in such case we are going to perform DFS from here. So DFS I comma j, so this is our source, and grid and visited. And once we have performed DFS, we are going to increase our answer by 1, and then towards the end all we have to do is return answer. Now let us look at the DFS function. So let us say we want to perform DFS. I and j, grid and visited, is given to us. So the first thing which we are going to do is we are going to mark I comma j as visited. After marking I comma j as visited, we are going to check the 8 directions which we have discussed. So let us understand this. So let us say this is my I comma j and we want to explore the 8 directions. So if we want to go up, then this coordinate will be equals to I minus 1 comma j. Similarly, if we want to go down, then this coordinate will be equals to I plus 1 comma j. In the same way, if we want to go towards right, then the coordinate will be equals to I comma j plus 1. Towards left, the coordinate will be I comma j minus 1. And let us explore the diagonals as well. So over here, the coordinate will be equals to I minus 1 comma j plus 1, and this coordinate will be equals to I minus 1 comma j minus 1. Similarly, this coordinate will be equals to I plus 1 comma j minus 1, and this coordinate will be equals to I plus 1 comma j plus 1. So we have to visit all these 8 neighbors. So let us do that. So first let us look at up. So if I minus 1 is greater than or equals to 0 and grid of I minus 1 comma j equals to 1, and this is not visited I minus 1 comma j. So if this condition is satisfied, then that simply means I minus 1 comma jth coordinate is a land which is not visited, because of which we have to perform DFS from there as well. So because of that, what we are going to do is we are going to call DFS on I minus 1 comma j on grid and visited. So that's about the up case, folks. Similarly, we have to look at the down case as well. So for that, if I plus 1 is less than grid dot len of grid and grid of I plus 1 comma j equals to 1, and it is not visited I plus 1 comma j. If this is the case, then we have to perform DFS on this grid as well. So for that reason, DFS of I plus 1 comma j grid and visited. And the same goes for left and right cases. So first let us look at the left case. So if j minus 1 is greater than or equals to 0 and grid of I comma j minus 1 equals to 1, and it is not visited. So in such case, we will perform a DFS on the left node as well. Now let us look at the right case. So if j plus 1 is less than len of grid of I and grid of I comma j plus 1 equals to 1, and it is not visited, then in such case we are going to perform DFS on this node I comma j plus 1. So far we have explored the cases of left, right, up and down. Now let us look at the diagonal cases as well. So for diagonal case, if I minus 1 is greater than or equals to 0 and j plus 1 is less than len of grid of I and grid of I minus 1 j plus 1 equals to 1, and it is not visited, then in such case we have to perform DFS over here as well. So DFS of I minus 1 j plus 1 and grid and visited. Similarly, if I minus 1 is greater than or equals to 0 and j minus 1 is also greater than or equals to 0 and grid of I minus 1 j minus 1 equals to 1, and it is not visited, then in such case we need to perform DFS on this node as well, I minus 1 j minus 1 grid and visited. So far we have explored the up diagonal. Now let us look at the down diagonal as well. So I plus 1 is less than len of grid and j minus 1 is greater than and equals to 0 and grid of I plus 1 j minus 1 equals to 1, and it is not visited, then in such case we need to perform DFS on this as well. So I plus 1 j minus 1 grid and visited. And the same goes for last diagonal, which is I plus 1 is less than len of grid and j plus 1 is less than len of grid of I, and this value, which is I plus 1 j plus 1 equals to 1, and this is not visited, then in such case we have to perform DFS on this node as well, which is I plus 1 and j plus 1, grid and visited. And in this way, we will be able to count the number of islands. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So folks, let us first look at the Python implementation. So in the discussion of pseudocode, I have used an additional space which is visited, but we can also code it without using additional space. So let us look at that solution as well. So the solution remains the same. It is just that rather than using an additional space which is visited, I'm going to track that information in the grid itself. So let us see how we have done that. So we are iterating on the grid, and if the I comma jth value, if grid of I comma j is equals to 1, then we are performing DFS, and then we are increasing our answer by 1, and towards the end we are returning answer. Now let us look at the DFS function, and folks, over here I'm not using any additional space. So in the DFS function, I'm marking grid I comma j as visited by marking it as 0. Then I'm checking the direction whether I will be able to move to those direction. If I'm able to move to those direction, then I'm performing DFS recursively on those directions as well. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. Over here I have used the visited array and the logic remains the same. So I'm iterating on the grid, and if this grid is equals to 1 and it is not visited, then in such case I'm performing DFS and increasing my answer by 1. Towards the end I'm returning answer. And in the DFS function, all we are doing is we are marking I comma j as visited, and then we are checking the 8 directions which we have discussed, whether we'll be able to move to these direction. If we are able to move to these direction, then we are performing DFS recursively on these direction. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.